Welcome to another episode of Tutorials with Ike. Today we're going to be looking at financial mathematics and the quantitative methods. If you are new to this channel, please don't forget to like, subscribe, comment, and share this video with your friends so that they'll also benefit from it. So under financial mathematics, you're also going to be looking at series and sequence as well as annuity, simple interest, and all that. But then for now, we're going to start with series and sequence. Now, when we talk about series and sequence, there are two types. We have the arithmetic progression and the geometric progression. Now, I explain them. So let's start with the arithmetic progression. So arithmetic progression. So it's the same as AP. So if you see AP, just know that it's arithmetic progression. Now, what is arithmetic progression? I'm going to use an example to explain it to you. Now, let's assume that each and every day your mom gives you one CD. So the first day she gives you one CD. That means now you have one CD on you. The next day she gives you another one CD. It means now you have two CD. Each and every day she gives you one CD. So the next day you have three CD. Then the other day 4 CD. Then so each and every day you are increasing your wealth by 1 CD. That's an arithmetic progression. So an arithmetic progression is a situation where you are increasing the numbers, you get it, by a common difference. So if let's say today she gives you 1 CD, the next day it has to be adding by 1. If you see 1, 3, 4, 5, 8, if they are not like there's no common difference, it's not an arithmetic progression. So for this one like this, you realize that 2 minus 1 is 1. 3 minus 2 is also 1. 4 minus 3 is also 1. She can also decide to be giving you 2 CD every day. So day 1, you have 2 CD. Then the next day, she gives you another 2 CD. So to be 2 plus 2, you have 4 CD. Then the next day, she gives you another 2 CD. So it means you have 6 CD. Then the next day, she gives you another 2 CD. It means you have 8 CD. So this one is also the same thing. You realize that 4 minus 2 will give you 2. 6 minus 4 will also give you 2. 8 minus 6 will give you 2. You get it? So this is a typical example of an arithmetic progression. You get it? But assuming you want to know, let's assume for this one 2, 4, 6, 8. You want to know, let's say, the 18th term or the 20th term. First day is 2 CD, second day is 4 CD, third day is 6 CD, the fourth day is 8 CD. Let's say you want to know what you get, let's say the 20th day, you get it, or the 30th day. You can use a formula to solve it so that you always not be adding up, you get it, it will be stressful. So you can just use a formula to find, let's say, what you'll be getting the 20th day or something, you get it. So for the formula, we use A plus into brackets n minus 1d. This is the formula to find the nth term. So assuming the question says you should find, let's say, the 15th term or the 30th term, you can't just be adding up. It would waste time, you get it. This is the first term, this is the second term, this is the third term, this is the fourth term. If you want to know, let's say, how much you get the 15th day or the 20th day or something, you can just use this formula for it. Now let me explain the formula. So the formula is A plus into brackets n minus 1d. This A is the first term. You get it. So this one like this, we have 2, 4, 6, 8. So our A will be 2. You get it. This one we have 1, 2, 3, 4, 5. So our A will be 1. Always the first term. Then n is the term you are finding for. So if you are finding for the 20th term, the 30th term. So assume the question says you find for the 30th term, then our n will be 30. If the question says you find for the 5th term, our n will be 5. The 4th term, our n will be 4. That's it. Then the D is the common difference. The common difference. And how do we obtain the common difference? The common difference is the second term minus the first term, or the third term minus the second term, or the fourth minus the third term. You get it? So either 4 minus 2, or 6 minus 4, or 8 minus 6. You get it? The second term minus the first term, or the third term minus the second term, or the fourth term minus the third term. For this one too, is the same thing. Either 2 minus 1, or 3 minus 2, or 4 minus 3, or 5 minus 4. So the one that is after minus the one that is before. You get it? And always the common difference has to be the same. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. Similarly, 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. So it's always the same. So assuming for this one like this, we have 2, 4, 6, 8. We wanted to find, let's say, the fifth term, the next number after this. We can use this formula to find for it. So the A is the first term. So what is the first term here? We have 2 plus n. Now we want to find the fifth term. So our n is now 5. So 5 minus 1. Then I said D is the common difference. So either the second term minus the first term, the third term minus the second term, or the fourth term minus the third term, any of them. So you can just take the second term minus the first term, which is 4 minus 2. So that would be 2. You get it? Similarly, 6 minus 4 will give you 2. So now we have 2 plus into bracket. So let's just simplify it. 2 plus into brackets 5 minus 1. 5 minus 1 is 4. Then times 2. So we have 2 plus 4 times 2 is 8. So our final answer is 10. You get it? So it means 2, 4, 6, 8. The fifth term will be 10. You get it? And obviously, if you are adding to the fifth term with 10, so we use the formula, we got the same thing. So that's how you find the nth term of the arithmetic progression. So if, let's say, each and every day someone is giving you 3 cities, 3 cities, 3 cities, 3 cities, and you want to know how much you get, let's say, the 30th day, the 40th day or anything, just make the 40 the n. You get it? Your difference is the second term minus the first term, or the third minus the second term. And the a is your first term. Then you can find your value. Do you get it? So that's how you find the nth term. Now, assuming you want to know the sum of all the terms, let's say the sum of the first 15 terms, the sum of the first 5 terms. Let's assume for this one 2, 4, 6, 8, 10. Assuming you want to know the sum and the numbers are, let's say, huge, you can also use a formula to find for it. Or let's say you want to know the sum of the first 20 terms, the sum of the first 30 terms, or even the first 100 terms. You want to know how much you are going to get or the value you are going to get. You can also use a formula to find it. Now the formula is, okay, let me clean this part. So the formula for that one, for an arithmetic progression is, so we have n over 2 into brackets 2a plus n minus 1d. So this is the formula for it. So the sum of n. So the sum of the n terms is n over 2 into brackets 2a plus n minus 1d. So if you want to know the sum of all the terms, let's say 2, 4, 6, 8, 10. These are the first 5 terms. You want to know the sum of the first 5 terms. You want to know the sum of the first 10 terms. The sum of the first 15 terms and all that. This is the formula you want to use. Now let's prove it. Assuming you want to know the sum of the first 5 terms, it will be the sum of the 5 terms is equal to, so our n is now 5 because you want to know the sum of the first 5 terms. You get it? So n is the number of terms. So to be 5 over 2 because the formula says n over 2. Then into bracket 2a, 2 into bracket. So a is always the first term. So our first term here is 2. So 2 into bracket 2 plus into bracket n. N is the same as what is here. So 5, which is the number of terms you want to find. So 5 minus 1. Then D is the common difference. So 4 minus 2 or 6 minus 4 or 8 minus 6 or 10 minus 8. So that will give us 2. Then we can punch all this on the calculator. You can also decide to simplify it. So we have S of 5 is equal to 5 over 2 into bracket 2 times 2 will give us 4 plus 5 minus 1 will give us 4. 4 times 2 will give us 8. You get it? So now we are getting 5 over 2 into bracket 4 plus 8. 4 plus 8 is 12. Do you get it? So we have 5 over 2 into bracket 12. Because 4 plus 8 is 12. 2 will go here 1. Or will go here 6. 6 times 5 will give you 30. So our final answer will be 30. What that means is that the sum of the first 5 terms, which is here 2, 4, 6, 8, 10, should give us 30. Let's try it. 2 plus 4 will give us 6. 6 plus 6 will give us 12. 12 plus 8 will give us 20. And 20 plus 10 will give us 30. So it means the formula is true. You get it? So if you want to find the sum of the first 10 terms, you just make here 10, then you get your answer. You get it? So those are the 2 things you need to know under arithmetic progression. Now I'm going to move on to geometric progression. Now what is geometric progression? You realize that for this one, the number just kept on increasing by a particular number. So for this one like this, from 2 we went to 4. You just needed to add 2. Then from 4 you go to 6. You just add 2. So 6 plus 2, 8. 8 plus 2, 10. If I want to know the next number, I'll just add 2, then I'll get 12. Then I'll be adding to that 12. But when it comes to geometric progression, the number keeps increasing exponentially. What that means is that if, let's say, I have 2, then someone can just decide to double it for me. So I'm doubling my points, you get it? So now instead of 2, I can get 4 because 2 times 2 is 4. Then from 4, I double again. So 4 times 2, 8. Then from 8, I double again. 8 times 2, 16. Then from 16, I double again. 60 times 2 is 32. Do you get it? So for this one, it keeps increasing exponentially. You get it? Not that they are adding a particular number. What you get determines what you get next. You get it? So this one like this, 2. Then after 2, it was 2 times 2, 4. Then 4 times 2, 8. Then 8 times 2, 16. 16 times 2, 32. You get it? So whatever you have will be multiplied times 2. You get it? It can also be times 3, times 4, times 5. But just know that it is increasing exponentially. You get it? Not that you are adding a number to it. What you have then to be multiplying. You get it? When you have a situation like that, we call it a geometric progression. And you also have a different way for solving it if you want to find the end term and all that. So let me clean the board so that we see how we solve that one where we have a geometric progression. Geometric progression. So that one is also called GMP. So just put to your head in case you don't see geometric progression, the same as GMP. So now, yes, back to the GMP. So this is an example of a geometric progression. This one, the numbers are increasing exponentially. You get it? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 60. 16 times 2 is 32. If I want to know the next number, I just multiply it times 2. You get it? So this one, we don't say it has a common difference because 4 minus 2 is 2. 8 minus 4 is not 2. You get it? 8 minus 4 is 4. 16 minus 8 is also 8. So you realize that the difference is different. But what you have in common is a ratio. You get it? Because 4 divided by 2 is 2. 8 divided by 4 is also 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So it has a common ratio, but not a common difference. So one of the features of geometric progression is that it has a common ratio. You get it? A common ratio. And if you want to find the end term of a geometric progression, assuming this one, we have the first term, second term, third term, fourth and fifth term. You want to find the sixth term. You use the formula AR exponent n minus 1. You get it? AR exponent n minus 1. Where A is also your first term. So this one like this, our first term is 2. Then R is the common ratio. If you want to find the common ratio, it's just the second term divided by the first term, or the third term divided by the second term, or the fourth term divided by the third term. You get it? So either 4 divided by 2. If you don't like it that way, 8 divided by 4. If you don't like it that way, 16 divided by 8. At the end of the day, you should arrive at the same answer. You get it? So now let's try for this. We have the first, second, third, fourth, and fifth. Let's find the sixth term. So if we want to find the sixth term, our A, like I said, is the first number. So our first number or the first term is 2. So 2 into brackets. Then our R is our common ratio, which is the second term divided by the first term. So 4 divided by 2 is 2. You can also do 8 divided by 4. You also get the same 2. Then exponent n minus 1. This one we want to find the sixth term because we have the first, second, third, fourth, and fifth. So let's find the next one, which is the sixth term. So our n becomes 6. If you want to find the 8th term, your n will be 8. The 10th term, your n will be 10. You get it? So if you want to find the sixth term, our n becomes 6. So 6 minus the 1, which is right here. So you can just punch this on the calculator and see what you are getting. So let's just punch it on the calculator. So we have 2 into brackets 2 exponent 6 minus 1. We are getting 64. 64. So it means our sixth term will be 64. Let's see if it's correct. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 will actually give you 64. So it means it's correct. You get it? So if I want to find the next term, the 7th term, if I also want to find the 10th term, I just make my n 10. I'll get the answer. You get it? If I want to find the 20th term, I'll make my n 20. I'll get the answer. It's as simple as that. Now, just like the first one, we're able to find the sum of the terms. So if you have, let's say, 2, 4, 8, 16, 32, and 64, you can also find the sum of all of them. Assuming you have, let's say, 20 terms, 30 terms, if you say you want to add all, it will take a very long time. So you can also use a formula for that. So let's clean it and see how we do it. So we have 2, 4, 8, 16, 32, and 64. So these are 6 terms. Assuming you want to find the sum for all these terms, which are the 6 terms, the formula is, so we have A into brackets R exponent n minus 1 over R minus 1. Or you can bring the R to this side. So or A into brackets 1 minus R exponent n over 1 minus r. So this is the formula you use if you want to find the sum of the terms of a geometric progression specifically. These are the formulas you use. Now, if your ratio is greater than 1, your common ratio is greater than 1, this is the one you use. This is the formula you use. But if it's less than 1, this is the formula you are going to use. Do you get it? So for this one like this, our common ratio was 2 because 4 divided by 2 is 2. So this is the formula we are going to use. But assuming we calculate and we get this is 0.5 or anything less than 1, this is the formula you are going to use. So just put it in your mind. Anytime the ratio is greater than 1, this is the formula you use. A into brackets r exponent n minus 1 over r minus 1. Then when the ratio is less than 1, you just interchange it. So the 1 will come to this side. So A into brackets 1 minus r exponent n over 1 minus r. Do you get it? And we want to find, let's say, the sum of all these terms. So 2, 4, 8, 16, 32, and 64. There are 6 terms. We want to find the sum of it. Our A is the first term. So the first term here is 2. So the first term here is 2. So 2 into brackets r. So 4 divided by 2 or 8 divided by 4. So 4 divided by 2 is 2. So our common ratio is 2. Exponent n. We want to find the sum of all these terms. This is 1, 2, 3, 4, 5, 6. So 6. Then minus 1. Then close the brackets over r minus 1. What is our r? Our r is 2, which is our common ratio, then minus 1. So we can just punch all this on the calculator. So let's punch it on the calculator and see. So we have a fraction in the numerator, 2 into brackets 2 exponent 6 minus 1 and close brackets over 2 minus 1. We are getting 126. So we are getting 126. What that means is that the sum of the first 6 terms will give us 126. And these are the first 6 terms, 2, 4, 8, 16, 32, and 64. So it means if we add all of this, it should give us 126. Let's check and see if it's correct. 2 plus 4 is 6. 6 plus 8 is 14. 14 plus 16 is 30. 30 plus 32 is 62. 62 plus 64 will give 126. So it means our answer is correct. You get it? So if you want to find the sum of the first 100 numbers, first 50 numbers, first 20 numbers, once you just put, let's say, 20 here, you should get the sum of the first 20 numbers. That's what it means. You get it? So this is how you go about it, as simple as that. So now let's take a practical question on geometric progression and arithmetic progression to see how we go about it. So let me clean the board. So it says, a manufacturer produces 1,200 computers in the first week. After week 1, he increases production by, so you have scheme 1 and scheme 2. So for scheme 1, you have 80 computers each week. Then scheme 2, 5% each week. Then I, find the output in week 20 under each scheme. Then find the total output over the first 20 weeks under each scheme. Then B, calculate for schemes 1 and 2 the week in which production first exceeds 8,000. Alright, so this is a typical question that could come in the exams, and all the questions that usually come are practical questions. So let's see how we are going to solve a question like this. So we have scheme 1 and scheme 2. Okay, so let's first understand the question. So the question says, a manufacturer produces 1,200 computers in the first week. After week 1, he increases production by, so they are now about to tell you the scheme for both of them. So it means for both scheme 1 and scheme 2, the first week he's producing 1,200. That means that's our first term. You get it? So let me just do scheme 1 and scheme 2 here. So we have scheme 1, then scheme 2. So scheme 2. So 1,200 computers in the first week. It didn't specify whether it's scheme 1 or scheme 2. So for scheme 1, our A or our first term is 1,200. Same as scheme 2, 1,200. Sorry. So yes, 1,200. So the question goes on to say after week 1. So this is for week 1. So after week 1, for both of them, it says for scheme 1, he increases production by 80 computers each week. You get it? So for scheme 1, which is this one, 80 computers each week. Then for scheme 2, 5% each week. he increases it by 5% each week. So let's start with scheme 1. If he increases production by 80 computers each week, and this is for the first week, it means for the second week, you are going to add 80 to this. So our second week, we are going to get 1,280. Because the question says he increases production by 80 each week. So the first week, they've already given it to us in the question, 1,200. But they say every week, he increases production by 80. So every week, you just keep on adding 80, that's all. So if week 1 is 1,200, week 2, you are going to add 80 to 1,200. I guess 1,280. Then if you want to know the value for week 3, what do? You just add 80 to this 1,280. So what is it? Let's try it on the calculator. So 1,280 plus 80. So you're getting 1,360. 1,360. You get it? If I want for week 4, I just add 80 to it. So you just keep on adding. You get it? And since you just keep on adding, we know that this is an arithmetic progression. Because I said for arithmetic progression, it has a common difference. You are adding by the same number. You get it? So since it has a common difference, this minus this should give you the same value as this minus this. You get it? So 1,280 minus 1,200 will give you 80. Similarly, 1,260 minus 1,280 will give you 80. So when you see anything like this, just know that it's an arithmetic progression. You get it? Now let's go to scheme 2. For scheme 2, it says he increases production by 5% each week. So that one, it did say 80 computers each week. It says he increases production by 5% each week. You get it? What that means is that if week 1 you have 1,200, week 2 will be 5% of 1,200, then you add it to it. Then week 3 will be 5% of what you have in week 2, then you'll be adding it to it. You get it? So if week 1 is 1,200, what is 5% of 1,200? So 5%, which is 5 over 100, because percentage is over 100, times 1,200. We are getting 60. You get it? 60. So 5% of this is 60. But it says he increases production by 5%. So he increases production by whatever you get. You get it? So 5% of the 1,200 is 60. So you're going to add 60 to 1,200. And that's how you know the value of week 2. So 60 plus 1,200 will give you 1,260. You get it? Because it says it increases production by 5% each week. Now, if you want to know what he's going to get in week 3, you take 5% of 1,260, not 1,200. Because it says he increases production by 5% each week. You get it? So you take 5% of week 2, which is 1,260. So 5 over 100 times 1,260. They are getting 63. So you add 63 to whatever you are getting in week 2. So 63 plus 1,260. You are getting 1,323. 1,323. 1,323. That's your third term. If you want to find the next one, you take 5% of 1,323. So 5 over 100 times 1,323. Then you add it to it. That's how you get the fourth one. You get it? So always you just take 5% of whatever is here. Then you keep adding it to each and every week. You get it? So now that you've understood the concepts, I believe you can answer the questions. So the first one says, find the outputs in week 20 under each scheme. Find the outputs in week 20 under each scheme. So we'll just start with scheme 1. So it's just asking for the 20th term. Output in week 20 is the same as the 20th term. What you are getting in week 20, you get it. This is what you are getting in week 1. What you are getting in week 2. What you are getting in week 3. You get it. So it's asking you for what you are going to get in week 20. You can't keep on adding. You'll be wasting time. And I said for arithmetic progression, now that you've identified that this minus this will give you 80, this minus this will give you 80, once you see that there's a common difference, you're getting the same value, it's an arithmetic progression. And how do you find the nth term of an arithmetic progression? I said that earlier on. So the formula is a plus n minus 1d. If you want to find the nth term or the particular number, you get it. So the 8th term, the 9th term, the 10th term, anything. This is the formula I'm going to use for an arithmetic progression. And I said A is the first term. So for this one, our first term is 1,200. So 1,200 plus, and it says week 20. You get it? So our n is 20. So 20 minus 1. Then multiplied by d. D is the common difference. So this minus this, or this minus this. 1280 minus 1200 will give you 80. 1260 minus 1280 will also give you 80. It's even in the question. So the common difference is 80. So you are getting 1200 plus into bracket 20 minus 1 times 80. So we can just simplify this. 1200 plus 20 minus 1 is 19. You get it? So 19 then times 80. You get it? So 1200 plus. So let's punch 19 times 80 on the calculator. 19 times 80. We are getting 1520. 1520. So now we have 1200 plus 1520. 1200 plus 1520. You are getting 2720. So our output in week 20 under scheme 1 is 2720. You get it? Yes, so 2720. This for scheme 1. Now let's go to scheme 2. So for scheme 2 too, we are asked to find the output in week 20. So the first thing we have to do is to identify whether it's an arithmetic progression or a geometric progression. How do we check that? Now, when we subtract this minus this, 1260 minus 1200, we are getting 60. However, when you subtract 1323 minus 1260, you are not getting 60. 1323 minus 1260, which is this minus this, you are getting 63. So you realize that it doesn't have a common difference. You get it? So now you know that it's not an arithmetic progression. So you check if it's a geometric progression. How do you check? You divide this by this. Then you put your answer down. Then you divide this by this. If they are the same, it's a geometric progression. So let's check and see. So 1260 divided by 1200, you are getting 1.05. 1260 divided by 1200. Then also 1323, which is here, 1323 divided by 1260. You're also getting 1.05. So you realize that it has a common ratio. And anytime it has a common ratio, it's a geometric progression. So now that we've identified that scheme 2 is a geometric progression, and we are asked to find the output in week 20, we know the formula for it. If you want to find the nth term or the particular term, the formula is, which I said earlier on, AR exponent n minus 1. You get it? AR exponent n minus 1. Where A is the first term. So the first term here is 1200. Then R is the common ratio, which we just solved for, and we got 1.05. Then N is the term you are looking for. So this one is said week 20. You get it? So our N will be 20, then minus 1. So let's just punch it. So A is 1200. The same as here. So the first term into bracket R. R is a common ratio. So when you divide this by this, you got 1.05. Then exponent n minus 1. The question says week 20. So our n is 20 minus 1. If the question says week 30, your n will be 30. Week 40, your n will be 40. That's all. So you can just punch it straight on the calculator. So when we punch it, we have 1200 into bracket 1.05 exponent 20 minus 1. So you are getting 3032. 3032.34 something. So we can just leave it as 3032. So our output in week 20 under scheme 2 is 3032. I hope you get it. So that's for the I part of the question. Find the output in week 20 under each scheme. So the output in week 20 under scheme 1 is 2720. Then the output in week 20 under scheme 2 is 3032. You get it. Now let's go to II. So II says find the total output over the first 20 weeks under each scheme. You get it. So what that means is that, so for scheme 1, so the first term plus the second term plus the third term up to week 20, when you add all of them, what are you getting? Same as scheme 2. And that one, I said the formula for that one is, so let me just clean here. When you are finding the total number of terms, or the sum of n terms, or the total output, when you see total number of anything, this is the formula you use. So the sum of n is equal to n over 2 into bracket 2a plus n minus 1d. So if you want to find the total output, this is the formula you use. So don't get confused. If you ask for the 6th term, the 7th term, the 8th term or something, use the first one. But if you are adding all of them, the total number of them, the summation, this is the formula you use. Under arithmetic progression, we've already identified that scheme 1 is an arithmetic progression. That's why we are using this formula. So now that we have that in mind, so the sum of the first 20 outputs will be n over 2. So n is the 20, which is in the question. 20 over 2. So n is 20 because they said the first 20 weeks. If they ask you for the first 30 weeks, the first 40 weeks, the first 50 weeks, that will become our n. So assuming the question said the first 50 weeks, our n would have been 50. This one, they said the first 20 weeks, that's why our n is 20. So 20 over 2 into bracket 2 into bracket A. A is our first term, which is 1200. Plus into bracket n. Our n is 20, so 20 minus 1. Then times d. D is the common difference. So this minus this or this minus this. So we established that our d is 80. So times 80. Let me just do it like this. So this is what you are getting. So n over 2, which is 20 over 2 into bracket 2 into bracket A. A is the first term, which is 1200 plus n minus 1, which is 20 minus 1, times the d, which is the common difference. 1280 minus 1200, we are getting 80. So times 80. So you can just punch all this on the calculator. Or let's just simplify it step by step. So 20 over 2 is 10. Into bracket 2 times 1200 will give you 2400. Then plus into bracket 20 minus 1 will give us 19. Then times our 80. So when we simplify this, we have 10 into bracket 2400 plus 19 times 80. So let's punch 19 times 80 on the calculator. So 19 times 80. We're getting 1520. 1520. So now we can punch all this on the calculator. 10 into bracket 2400 plus 1520. We're getting 39,200. So that's for our scheme 1. So the total output over the first 20 weeks under scheme 1 is 39,200. So the first week plus the second week plus the third week plus the fourth week plus the fifth week up to the 20th week will give you 39,200. That's what it means. Now we can also do for scheme 2. How do we do for scheme 2? So let me just clean this part. So now we move on to scheme 2. And scheme 2, we identified that it's a geometric progression because it has a common ratio. And I said for a geometric progression, if you want to find the total number of terms or the summation, you use the formula A into brackets r exponent n minus 1 over r minus 1. Use this formula when the r or the common ratio is greater than 1. This one, we realize that our common ratio is 1.05. That's why I'm using this. If the ratio was less than 1, it would have been A into brackets 1 minus r exponent n over 1 minus r. But because our ratio or our common ratio is greater than 1, that's why I'm using this formula. So let me clean it. So now we want to find the total output over the first 20 weeks under scheme 2. So this is the formula we use. So now that we've got the formula, let's just substitute it. So we have A into bracket. So our A is 1200 into brackets r exponent n. And r is the common ratio, which is the second term divided by the first term or the third term divided by the second term. You get it? So 1260 divided by 1200. When you punch it on the calculator, we got 1.05. 1.05, which is our ratio, exponent n. They said the total output for the first 20 weeks. You get it? So our n is 20. Then minus 1. Then all this over r. R is 1.05 minus 1. You get it? So you can punch it like this on the calculator. So let's punch it and see what you are getting. So for the numerator, we have 1200 into brackets 1.05 exponent 20 minus 1. Then for the denominator, we have 1.05 minus 1. So we are getting 39,679. 39,679. So approximately 39,680. So our total output over the first 20 weeks under scheme 2 is 39,680. That's how we go about it. So when they give you the question, if they don't specify whether it's an arithmetic progression or a geometric progression, the first thing you do is that you first identify whether it has a common ratio or a common difference. If you subtract the second term and the first term, and you get, let's say, 5, and you subtract this minus this, you also get 5, then straight away you know that it's an arithmetic progression. But when you subtract the second term and the first term, you subtract the third term and the second term, you are getting a different answer. Then you know that it's not an arithmetic progression. So you go ahead and divide and see if you get a common ratio. If you divide the second term and the first term and you get one answer, let's say 5, and you also divide this and this, you also get 5, then you know it's a geometric progression. They use the formulas for it accordingly. I hope you get it. So let's move on to the B. The B says, calculate for schemes I and II the week in which production first exceeds 8,000. Alright, so let me clean the board so that we solve it. So the B says, calculate for schemes I and II the week in which production first exceeds 8,000. You get it. So let's start with scheme I. So scheme I. So the week in which production first exceeds 8,000. So anytime you are given a question like this, you just equate the formula for the n term, which is a plus n minus 1d. Do you get it? So the 8,000 they've given to you, because you know that a is the first term and n is the week. Do you get it? So for week 1, our n was 1,200. For week 2, our n was 1,280 because we are adding 80. Do you get it? And now we want to know the week in which production will first exceed 8,000. So we'll have to make n the subject here. Do you get it? And equate this to 8,000. So anytime they give you a question like this, just equate the formula for the nth term to 8,000. We know it's an arithmetic progression. This is the formula for the nth term. And now we want to find n when it is equal to 8,000. This is the number of weeks. So when this is equal to 8,000, you get it. So we just have to make n the subject. Alright, so from here, we know that our A is 1,200 from the question. You get it? So our A is 1,200, then plus our n. We don't know the n. That's what we are going to make the subject. So n minus 1. Then D is 80. You get it? That one was already identified. So times 80 is equal to 8,000. So now our job is to make n the subject. So how do we do it? We can send 1,200 to this side. So we have into brackets n minus 1 times 80 is equal to 8,000 minus 1,200. So 1,200 will come here and become negative. So minus 1,200. Do you get it? So we have n minus 1 times 80 is equal to, so 8,000 minus 1,200. 8,000 minus 1,200. I'm getting 6,800. 6,800. Since we want to make n the subject and n minus 1 is multiplied by 80, we can just divide both sides by 80 to make our simplification easier. So divide here by 80. We also divide here by 80. So 80 will cancel 80. So we have n minus 1 is equal to, so 6,800 over 80. So 6,800 over 80. We are getting 85. 85. So 6,800 over 80 will give you 85. So our n will be equal to 85 plus 1. 1 will come here and become addition. So our n will be equal to 86. Yeah, so that's our final answer. So the question says, calculate for schemes I the week in which production first exceeds 8,000. So in week 86, that's when the production first exceeds 8,000. You get it? That's what it means. So anytime you have a question, once again, just equate this formula, which is the formula for the nth term, to the number of, or the output they're giving to you. So for this one, they give us 8,000. That's why we equated it to 8,000. Then you just make the n the subject. That's all. Now we do same for scheme 2. So let me clean it and do the same thing for scheme 2. So we do same for scheme 2, but we know that scheme 2 is a geometric progression. So this time, the formula for the nth term is AR exponent n minus 1. You already know that. Then you also equate it to 8,000. You get it? So you do the same thing. You just equate the formula for the n term to the 8,000. Then we make n the subject. That's all. So our A is 1,200, which is in the question. And our common ratio, which is our R, which we already identified earlier on, was 1.05. I hope you remember that. Then exponent n minus 1. We are making n the subject, so we don't know n right now. That's what we are finding. Then we create it to 8,000. So now we are asked to make n the subject. So how do we make n the subject? We can divide both sides by 1,200. 1,200. So we can divide both sides by 1,200. So here will cancel here. So to be left with just 1.05 exponent n minus 1 is equal to, so 8,000 over 1,200. So 8,000 divided by 1,200. You are getting 6.66667. So let's do 6.67. 6.67. Alright. So we want to make n the subject, but n minus 1 is an exponent. You get it? So we have to take the natural log of it. Anytime you want to make an exponent the subject, you take the natural log of it. And anytime you want to make something the subject and it's an exponent, you multiply it by what is here, which is the base, before you can take the natural log of it. So for the right hand side, you just take the natural log, which is ln 6.67 here. But for here, since you have an exponent here, you multiply this times this before you take the natural log. So n minus 1 times ln 1.05. Do you get it? So just put it in your head. When you have an exponent like this, it multiplies the base before you take the natural log. Under normal circumstances, it should have just been ln 1.05 is equal to ln 6.67. But because there is an exponent here, it multiplies this first. So to be n minus 1 times the natural log of it. That's how you go about it. So now that we know this, we want to make n minus 1 the subject. But n minus 1 is multiplied by ln 1.05. So we divide both sides by ln 1.05. We also divide here by ln 1.05. So this will cancel this. So n minus 1 will give us, so we do it one by one. So ln 6.67, ln 6.67 will give us 1.8976. So let's do it 1.9. So n minus 1 is equal to 1.9. 1.9 is the ln 6.67. Then over ln 1.05. So ln 1.05. You're getting 0.048. So let's do 0.049. 0.049. You get it. So n minus 1 is equal to 1.9 over 0.049. So 1.9 over 0.049 should give us 38.77. Let me continue somewhere here. So n minus 1 is equal to, so we have 1.9 over 0.049, and this gives us 38.775. So let me just make it 776. So 38.776 is 7755, but when you round it, you can get 776. So now we want to make n the subject. So to be n is equal to 38.776. Then the negative 1 here will cross the equal sign to become positive. So plus 1. So finally our n is, so our n is 38.776 plus 1. So you are getting 39.776. 39.776. So approximately 40, because it's almost 40. You get it? So the week in which production exceeds 8,000 under scheme 2 is 40. So in week 40, that's when production exceeds 8,000 for scheme 2. Do you get it? So anytime they give you a question, this is how you go about it. You get it? Very simple. So anytime they give you a question on this is how you go about it. So most of the questions are practical, especially in the past questions. So try and take your time to solve a lot of practical questions on this particular topic because it comes a lot. Do you get it? Thank you very much for watching today's video, and I'll see you in the next video. In the next video, still under financial mathematics, we're going to be looking at annuity, simple interest, compound interest, and all that. So I'll see you in the next video.